Alright, so this will be my explanation for assignment 1. We're going to just go through my code, talk a little bit about it. So, as far as all the values I claimed up here, right, just R1, R1I, that stands for the first value and the first imaginary value. Same with R2 and R2I, and then R3, R3I. And then once I switch the letters over here, that's just going from Y to delta. So realistically, I have 6 for delta to Y and 6 more for Y to delta. And then this is just where you're inputting it down here, right? Then, based off that, basically calculating the magnitude of each of those. Because since we have real and imaginary, we have to calculate the magnitude. We can't actually use math with those yet. From there, I'm basing just the equations off of the conversion that you gave to us in a PDF and printing those values out. And that is just from delta to y. And then, just real quick, I kind of skipped over this. The do loop at the top is, you see it all the way at the bottom. This is what's making the whole code loop. So you see I have highlighted right here in the print. Basically, if you would like to run the code again, enter 1 for yes and 0 for no. So if they enter anything else other than 1, it's not going to loop. And if they do enter 1, the whole code loops again. And it doesn't matter that these are outside of the do loop because those values change once they re-enter the values. So no problem there. And then as far as I have that loop, and then right after is the big choice section of whether they're going to be in delta or y. So every time they loop, it reprompts them for delta or y. And then from there, there's the if, and then there should be an else if down here, yep, for if they choose w. And very similar here, having them enter the real and imaginary values of each of the impedances, and then calculating magnitude and going on the equations from there. And then if they were to not enter w for y or d for delta, then it would just tell them you're neither in delta or y, program will now end, and then they'd be prompted on if they want to re-input again or not. But for test reasons, I'll run the code now. So first we'll go delta, then we'll go 1, 2, 2, 1, and then 1, 1. And then gives you all your values here. All looks good. So we want to run it again? Sure. Right, we're going to go in y. We'll go 1, 1, 1, 2, 2, 1. Then it gives you values for your delta to y. So that just does the conversion for you. And then say we want to end the code, I'll just enter 0. Code is now over. Closes it out. But as far as that, pretty straightforward. I'd say biggest things I had to get right here were just whether the user wanted to keep looping or not, and the choices. Other than that, it was a lot of just math going on in here. I definitely could have done all of these numbers. I could have made them an array, had them go from 0 to 2, so 0, 1, 2 for all real ones, and 0, 1, 2 for all imaginary ones, and just looped it. As far as that, math here, just the square root of this whole thing, and then the power, so this would be the square root of r1 squared, square root, so this is the square root of the real component squared plus the imaginary component squared. That's what all of these are doing, just to get your actual magnitudes of all three, and then I'm using those values there. And as you can see, same thing happens down here, taking magnitudes, but the math itself is just different. And yeah, that's all I got.